Hi guys, today's lesson is on inverses and compositions. And so what I had written up here originally is kind of related, but we ended up changing things because of the way our book is organized. So it's really just about inverses and compositions today. So that's what our goal is for today, is to do some compositions and then transformations. That's what we were doing the other day with our graphs. But let's talk about inverses and compositions, because we know already that logs and exponents are inverses of each other. So they basically cancel each other out. When we learned this back in our previous unit and we did compositions, we found out that when you take f of g of x, if they are compositions of each other, then they reduce down to just x. And so that should work out for exponents and logs as well. So let's take a look. Remember, when we have f of g of x, that's what this means, and this little dot is not a multiplication, it's a composition. So we're going to take the g of x and we are going to plug it in to the f of x. So what we're going to get is that f of g of x is equal to 3 to the power of log base 3 of x. So I just took that x and I plugged that whole log into it. And so I tried to make my 3 really big so that those could be exponents. All right, well, when we've talked about logs, we've been talking about how they are inverses of each other and so forth. And so if you have inverses, they are supposed to cancel each other out. And that's what happens here. This 3 and this exponent are both a base 3. So a 3 with an exponent of base 3 are actually going to cancel each other out. And this is just going to reduce down to f of g of x is equal to x. So that 3 and the power of 3, the log base 3 and the exponent of 3, cancel each other out. Let's take a look at another example. This time we're going the other way. So this time we're going to take f of x and we're going to plug it into the log of x. So when I do this, I'm going to take the log base 3 of, and I'm going to put in 3 to the x power. And so again, we have log base 3 of 3 to the x power. Well, the log base 3 and the 3 to the power of something with an exponent, they end up canceling each other out. And so our final answer is g of f of x is equal to x. So logs and inverses cancel each other out, and we're left with just the x. And so that might be something you want to write down in the margin, that log base b of b to the x, it cancels down to x, and b to the power of log base b of x also cancels down to x. Okay, the next concept is finding inverse functions. And I don't know if you remember when we did this before, what we're going to do is we're going to switch our x with our y, and then we're going to solve for y. So let's go back and look at this. Remember, we started off with calling this y, and then we switched the x with the y. And now that I have this, I'm actually going to solve for y. And so I'm going to subtract 2 from both sides. Now I have a y in my exponent. And so how do I get rid of the y in the exponent? Well, before I even do that, address that question, I want to get rid of that negative sign. I don't like that negative being there, so I'm going to divide by -1 on each side. And so if I divide on -1 on each side, then I have a negative of this equal to 4 to the y power. I'm going to rewrite that up here so I've got some space. So I really have a negative x plus 2, right? If I distribute that negative, I get a negative x plus 2. And then over on the right, I still have 4 to the y power. All right, now I need to address that question I was talking about, is how to get rid of that, because we haven't really talked about that yet. Well, what I'm going to do is I'm going to use that rule that we just learned up above. In other words, I'm going to take the log base 4 of both sides. All right, why did I take log base 4? You have to specify what base you want, right? And in this case, I chose log base 4. And the reason that I chose log base 4 is because that way we can use that rule that we just learned up here, that log base 4 and a 4 to the power of something cancel each other out. And when they cancel each other out, all we're left with is the y. On the left, I still have what I had a second ago. That is, I have log base 4 of negative x plus 2. And now I'm finished. My inverse function is finished. Okay, I went through, and just when we're solving, let's think about this. When we're solving equations, we use inverse operations. So here was a plus 2, so I subtracted 2. There was a negative 1. This is basically a negative 1 times, right? So I divided to get rid of that. And now I had a power, and I had to figure out how to get it out of the power. Well, the inverse function of exponents is logs. So I had to take the log so that the inverse functions would cancel each other out. And that leaves me with my inverse function. And we talked about this before, that this basically should be like the opposite. And so that's basically what I've done. I've come up with the opposite equation. Let's look at one more example. Okay, so here we have our g of x. It's a little bit longer than the last one. We're wanting to find the inverse. To find the inverse, I'm going to call this side x, and I'm going to call this one y. And now I need to isolate that y, so I have to basically move everything else over, right? So I'm going to start by subtracting 7. Now, what can I do? I can't really add that 3 because it's the log base 5 of 3. I can't separate that out. So I have this log base 5. How am I going to get rid of log base 5? Well, just like a minute ago, we had an exponent, so we did a log to undo it. Well, now we have a log, so we're going to do an exponent to undo it. In other words, I'm going to take the left-hand side, 5 to the x minus 7 power. And on the right-hand side, I'm going to take 5 to the power of log base 5 of y minus 3. Seems a little bit long and crazy, but all I've done is taken 5 to the power on both sides. And we actually did something like that the other day when we were solving for those logs that had fractions. So anyway, we're sticking with that concept. And the reason is 5 to the power of log base 5, that 5 and that log base 5 will cancel each other out. And so on the left, I still have 5 to the x minus 7. And on the right, those cancel out, and I just have a y minus 3. Just trying to get y by itself, so I'm still not there yet, but I can go ahead and add 3 to both sides. When I add 3 to both sides, just be careful when you write it that it's not part of the exponent also. I'm out of space, so I'm going to come over here. And I'm going to have 5 to the power of x minus 7. And then I don't know if you want to put that in parentheses. I'm going to go ahead and maybe put that whole thing in parentheses and then say plus 3. And so now my y is all by itself. So now I'm done with the equation. I have the inverse of g is 5 to the power of x minus 7 plus 3. And that time when I wrote it, I put the x plus 7, the exponent, in parentheses. Maybe that helps you see what's going on. Just make sure that that x minus 7 is separate from the 3. The 3 is like a big normal 3. The 5 is like a big normal 5. But the x minus 7 is the power. All right, tomorrow in class we will do a little bit of work on this. But this concept will not be covered on the quiz that's coming up. So this concept will go on to the next section later, but I wanted to make sure we had time to get it in before, but our quiz will not cover this. Summary. Let's go ahead and write a few things down in the summary. You can write down in there what you think you want to write down, but I have a couple things that are options for you that you might consider adding to your summary.